Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over a related rates example involving a trapezoidal prism trough. Okay, so let's go ahead and take a look at the instructions. It says the ends of a horizontal water trough is an isosceles trapezoidal prism, as we can see illustrated here. The length is 8 feet and the lower base is 4 feet. The upper base is 10 feet and the depth of the trough is 2 feet. If the water level is rising at 3 feet per minute when the depth of the water is 1 foot, how fast is water being poured into the trough? Okay, so let's start by populating the dimensions of this figure with the values we have here. So we know that the length is 8 feet. So this length right here, from here to here, is 8 feet. So let's mark that down. This is 8 feet. All right, and then the lower base is 4 feet. So this lower base right here is 4 feet. And then what else do we know? The upper base is 10 feet. So this base right here is 10 feet. And then the depth of the trough is 2 feet. So basically how deep it is from the top is 2 feet. So let's go ahead and put that measure there. From here to here is 2 feet. Okay? All right, so to set up our related rates equation, what we're going to do is pick an arbitrary um, height. Let's assume that the water got filled to a certain height. Let's say this arbitrary height right here. Um, and then the height of this water level is h. And let's just call this part right here h, and let's call this x. Okay, now since this is an isosceles trapezoid, we're going to have a congruent triangle over here, and this will be h, and this will be x also. Now, if we extend this portion all the way up, we can also divide it amongst the 4 and the 10. So we have this segment right here is this is 3, this is 3, and this is 4. How do we know that? Well, if we take 4 out of 10, we're left with 6, and when you divide it by 2, you have a 3 here, and then you have a 3 there also. All right? Okay, now this is just an arbitrary height, so let's assume that we fill the water up to this level. So the question now is, what is the volume of the water if we fill it up to this arbitrary height, h? Okay, so over here we're going to write down the formula for the volume of a trapezoidal prism. So the volume of any prism is the area of the base times the perpendicular height. Okay? In this case, the base is an isosceles trapezoid. Okay? And so the volume is going to be 1/2 times base 1 plus base 2 multiplied by the height of the trapezoid. This is the area of the um, base times the height, big H. Okay? Now let's take a look at this situation we have right here. We're finding the volume of this this portion right here, the water level at H. So this B1 is going to be the smaller base, B1 right here, and B2 is going to be this base right here, from here all the way to there. Okay, so that's going to be B2. All right, so if we take a look at what's happening here, this section is x, this is x and x, so the center is going to be what? It's going to be 4 units long, okay? So let's go ahead and put it on our measures. So we have the volume V is equal to 1/2 times base 1 is 4. That's constant. It doesn't change. Base 2 keeps changing as water gets poured into the trough, okay? Now in this situation, base 2 is going to be 4 plus x plus x. Okay, so it's going to be 4 plus 2x. That's what base 2 is, all right? And then our h is still h. And then this is big H right here. Big H is how long your trapezoidal prism is, so that's 8 units long. Okay? All right, let's simplify this a little bit more. So we're going to have V equals, we can take 1/2 of 8, that's 4. 4h times 4 plus 4 is 8 plus 2x. And then we can distribute this 4 in here. And then we're going to have V equals 4 times 8 is 32h plus 8 xh. So this is a volume in terms of two variables, okay? H and x. So what variables do we need to substitute if necessary in order for us to figure out what the uh, related rates is? In order to determine what variables need to go and what variables need to stay, we need to go back to the problem and look at the related rates we are given and the rates that we need to find. Okay, we need to identify the rates that are given and the rates we need to find. Okay, any rates that are not mentioned need to be substituted, whatever variable is connected to that rate. So here it says the water level is rising, level rising. If you're measuring how the rise, that's the height. So this value right here, 3 feet, is talking about the rate of change of the height. So this is dh dt, okay? And then it says when the depth is of the water is 1 foot, how fast is the water being poured? Water being poured into the trough is talking about the volume. So this is dv dt. All right, this is what we're looking for when the HDT is 3 feet per minute, okay? All right, so we just need a formula that relates the volume and the height. That's all we need, okay? So if you take a look at this formula right here, we have x, we have height, and we have v. So what has to go? X has to go, okay? If we do not get rid of x, and we differentiate implicitly, we will have a dx dt component that we do not know what it is, all right? So how do we express x in terms of h? We're simply going to use similar triangles, all right? If you look at this triangle right here, we can set up a similar triangle situation and use that to determine what, we can use that to formulate an expression to express x in terms of h, all right? So there goes our two similar triangles. This is h, and this is x. This is 3, and the entire height is the depth of our cylindrical trough, which is 2 feet. Okay, so this entire depth right here is 2. So can you see a ratio? Since if two triangles are similar, then corresponding sides are proportional. Okay, this side corresponds to that side, this side corresponds to this side. So we have x over h equals 3 over 2. If we isolate x, we're going to have x equals 3 over 2h. All right, so we're going to plug this back into x here. So we're going to have volume in terms of just h is going to be 32h plus 8 times 3 over 2h times h. So the volume in terms of h, we simplify further, is 32h plus 2 goes here 1, 2 goes here 4, 4 times 3, 12, 12h squared. Okay? So let's go ahead and differentiate implicitly. Derivative of v is just 1, dv dt. Derivative of 32h is 32. The h dt, remember we're differentiating with respect to time. Derivative of 12h squared is 24h. The h dt. Okay? We have to find dv dt when the water level is rising at 3 feet per minute, so the h dt is 3, and the depth of the water is 1 foot, so that is h. Okay, so this value right here is h equals 1. All right, so we have h equals 1, the h dt equals, oh snap, I forgot already, 3. The h dt equals 3, so we plug those in here. So we have dv dt equals 32 times the h dt, which is 3, plus 24 times h, which is 1, times the h dt, which is 3 again. All right, let's simplify this. This becomes 96 plus 24 times 3 is 72. Add these two together, we get 168. All right, so the unit is feet cubed per minute. All right, so our answer, the meaning of our answer is that water water is being poured into the trough at 168 feet cubed per minute. Okay, so there goes the answer. Thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. More clips can be found on mathgotserved.com. If you have any questions or would like to request any tutorials, feel free to request it in the comments section below. Thanks again for watching and have a wonderful day.